All right, everyone. Good morning again. Now we are going to have another talk on achieving developer autonomy on on-premise data clustering using Kubernetes. This is a talk from one of our sponsors, Adyen. So Yorick is going to walk through us through the whole process. And yeah, let's see what questions we can get.
All right. I was expecting an empty room, but this is very different from what I expected. So yeah, good to have you all here, and thanks PyData for inviting me. Yeah, so I'm Sleijster. I'm data platform engineer at Adyen. I've been working there for almost 3 years, and in my spare time, I play a little bit of tennis and padel. So if you want to play padel in Eindhoven, then hit me up, because that's where I'm from. Yeah, so this is the table of contents. This is a very important slide, I was told, but yeah, we have 87 more slides to go, so let's go. What does Adyen do? Adyen is a payment provider, and these are our customers, and they all believe that Adyen provides a unique product that gives them a competitive edge over their competitors. And you'll probably know quite some of them: Spotify, McDonald's, who doesn't like their hamburgers, Subway, and the single people probably know Tinder all the way at the bottom. Yeah, so a lot of customers. And that also means that we don't just do data, but we do big data. And one important detail to this is that we do everything on-premise. So that means that we own the servers ourselves, and when a hard drive goes bust or when a CPU goes bust, we actually have someone that replaces that hard drive or replaces that CPU. Yeah. Furthermore, we're also doing everything open source, and that definitely limits us in what we can do compared to when you're on the cloud. Let's go into the teams and responsibility. So how is Adyen built up? First of all, we need someone that actually manages the server. So these are the infrastructure teams, and these are the ones that have root access to the machines, because everyone knows it's not a good idea to give 3,000 employees access to all the servers with root. So that's why we have dedicated teams that manage the servers. Then we have the tooling teams. That's what I'm a part of. Here we have the data platform engineers, data engineers, and they install the tools on the machines together with the infrastructure teams. So stuff like Spark, other APIs, yeah. So, and they really try to help out the product teams as much as possible to achieve their goals. And the product teams consist out of the data scientists, data engineers, data analysts, and these are the ones that generate insights for our business or for our customers, the ones that create machine learning models to detect fraud. We've also had a presentation from our colleagues yesterday how we use graphing databases to detect fraud. Yeah, so that's kind of how it's built up. And that also shows in terms of the number of people. At the top, we really have only one team that helps us out on the big data side, so that's around 15 people. Then we have 4 tooling teams, and we have 20+ product teams. But when you look at the waiting game, when we want to install a new software, let's say we want to change the configuration in Airflow, or some years ago we introduced MLflow. Then what happens is the tooling teams does all the research, but then at some point you want to install it on the machine, and that's where you need the infrastructure team. And of course, they have a lot of things on their plate. They don't just do big data. They manage all the servers. So there's a lot of, not all the servers. They manage a lot of other servers as well. So anytime we knock on their door, there was a little bit of waiting time. But what happens when the product teams want to introduce new stuff, like Dask, or they want a fancy Streamlit app, which is the new way to visualize your insights? Then they'd have to come to us, we'd help them out, but then again, we'd also have to wait for the infrastructure team to, again, deploy the things on the machines. This all takes a long time. Can I get a show of hands of whom of you are on the cloud? All right, that's a lot of people. Yeah, it really is a magical place, right? With the click of a button, you have a storage layer that can hold petabytes of storage. With an API call, you can spin up a Spark notebook. Or when you need analytical queries, just another button, and you have a Presto cluster up and running. And it really is amazing. So it really blows my mind. But right, we are not on the cloud. And now, anytime we deploy a new application, we go through this waiting game. Now, let me show you how many applications we actually have. Of course, we have Spark. Then, to actually launch our Spark batch jobs, we have Yarn. Then we have HDFS for storage. We also have Jupyter Hub. It's appearing on the screen, but not on my MacBook, so that's weird. Then we have Airflow to schedule those jobs. Then we have MLflow, TensorFlow, PyTorch, SynapseCML, XGBoost, LightGBM, Dask, Trino, Druid, Postgres, Kafka, Elasticsearch, Streamlit, Puppet, Ansible, LDAP, Kerberos, Hive, Apache Ranger. That's a lot of waiting. And that's a lot of tools, right? So yeah, something had to change, because we can't just be reliant and waiting every single time we want to do a single change. So the goal is really achieving higher velocity, and we want to do that by giving more autonomy to all the developer teams. So that includes the product teams and the tooling teams. The product teams want to introduce new tools by themselves, so stuff like Flight or Streamlit. And the tooling teams, they just want more autonomy in managing the applications they already have, and also possibly introducing new applications. So anytime I want to change the configuration in Airflow, then I don't want to go knock on somebody else's door. I want to do it myself. So this required us to make quite some changes. And the first change was we wanted to be able to deploy any application with ease. And this is where the resource orchestrator comes in, which we'll discuss next. We also wanted to deploy any change automatically, because everybody knows if you deploy it manually, you'll forget stuff. So that's why we're going to talk about GitOps. Then we want to be able to update our application without infrastructure approval, while sort of keeping a safe environment. That's where multi-tenancy comes in. And then we want to connect the different applications together that we're creating. And this is where you often use secrets to connect them together. So we needed a decent secret management. And finally, we wanted to migrate our current applications. So yeah, what is a resource orchestrator? A resource orchestrator schedules your jobs on your server. So let's imagine you have 5 servers. Well, actually, at iGen, we have tons of servers. But let's just get back to this example with 5. So we have 5, and we want to create a report. So this is a Spark job, and it's a very small report. So this can just be launched on a single server. Again, next report comes along, can also be spawned on a single server. Then the third report comes along, and now it tries to schedule it on the first server, but the resource orchestrator will know this server is already packed with jobs. This can't be scheduled there, so it will schedule it to the next server. Now, when a big job comes in, so a very large report, then we need to distribute the workload across the servers. And this is also the job of the resource orchestrator. So a single one won't work. Instead, we schedule it to all 3 servers. And now, preferably, we don't just want to be talking about reports and Spark jobs and Dask jobs, but we also want to run any arbitrary application. So just any sort of container like MLflow. Yeah, but unfortunately, as you might have seen on the previous slides, we use Hadoop Yarn as a resource orchestrator. And that doesn't really work for the above-mentioned case. Because anytime you want to run a specific application, you need to install it on the servers. And that means that some way or the other, you have to SSH into the machine to install it. And that requires someone from infrastructure to do it. Furthermore, it can't just run any sort of application. It can only run batch jobs. And the community has mostly moved on. And that means that when there's an issue, that would mean we'd have a really hard time finding someone that can help us out. Also, new tools, they don't support Yarn out of the box. They support Kubernetes out of the box. So yeah, Yarn wasn't really a good fit for us. But what were the options we considered? We kind of had 3 options. The first one was Yarn, so to keep using the tools we currently had, but that's not really a great option for us. Second one was switching to Kubernetes. And the last one was switching to HashiCorp Nomad. Can I get a show of hands of the people who've ever heard of HashiCorp Nomad? All right, that's quite a few people still. So for the ones that don't know, HashiCorp Nomad is like a Kubernetes alternative. They approach things a little bit differently, and it might work better for your use case or less. In our case, we already had Nomad clusters in Adyen, but still, we decided to go with Kubernetes because all of the tools for big data, they come out of the box with Kubernetes support. So it doesn't make sense for us to spend months on rewriting Nomad integrations for every new tool we want to integrate. So yeah, that's why we went for Kubernetes. And now the first question you have to ask yourself when you're on-premise, which is not something you ask yourself when you're on the cloud, is what Kubernetes distribution do you use? And actually, there are tons of them. And these are just the ones, like the first 20 I took of a list of 60. So you probably know a couple of these, like we have Google, we have Azure, AWS, Alibaba, DigitalOcean. Well, all of these are cloud provider distributions, so you need to be on that specific cloud to use it, so we can remove those. Then we have a lot of them remaining, and yeah, I can't take the one with a ketchup bottle logo seriously, so let's remove that one as well. And then we looked, because we're a payments company, it needs to be very secure. So we looked at all the options, and then there's one that really shines out, and this is RKA2. This is the distribution that's also approved by the US government to be used. That made us believe it's more secure as well. So that's why we went with RKA2. So how do developers deploy their YAMLs? Okay, so we have this Kubernetes cluster now. It's running RKA2. And the next step is how can we deploy the applications that we want to deploy? Well, there are multiple options here. The first thing is the developer does it himself, and that's not really great because this guy is laughing right now, but when he leaves the company in a year, he doesn't tell you about all the manual hacks he did to get these applications up and running, and that will mean that when he's left the company, so does all the applications he introduced because you need to redo everything. Then there's the second option, CI/CD, where you run pipelines to automatically deploy to your cluster. And then the last option is GitOps. And GitOps is more something listening on your branch, on your Git repository, and then deploying it on the Kubernetes cluster. So the difference between CI/CD and GitOps is CI/CD is push-based, so you have some pipeline pushing the code to your Kubernetes cluster, where the GitOps is constantly pulling the Git repository for changes and then applies it on the Kubernetes cluster. And usually this GitOps tools also run inside the Kubernetes cluster. You also have tags and branches with CI/CD, where with GitOps you usually really use only a single branch. And with CI/CD you have, when you revert your work, you might also have to retag, where with pure GitOps you really only have to do a revert of your commit. So for us it was a pretty easy decision. We really liked Argo CD, so we had a happy octopus. What does it look like when you deploy some manifest? So in the background here, I am typing a new commit, new application, just a very simple web server. And then I make the commit. Argo CD is refreshing the branch. It noticed there was a change. And boom, before you know it, it's deployed. So what we have over here is at the top, we have a service. Then we have a deployment. And then finally, we have an ingress. And Argo CD, what it just did is it loaded the branch in, it saw all the Kubernetes manifests it needed to deploy, it checks whether they're already deployed, resolves it, and then deploys the changes. All right. Now you might wonder, this is a really cool tool, but does this mean that developers can update whatever they want, or do you use some sort of multi-tenancy? Then the question might be, what is multi-tenancy? Because it's not a very known word. Well, what we define first is we have a user. In this case, it's a team, so a team inside Adyen. And they get a namespace for a single application, and they would deploy that on a Kubernetes cluster. So what you see on the cloud usually is that every team spins up their own Kubernetes cluster, because spinning up a Kubernetes cluster is really cheap. And then they have a couple of namespaces per team because they have different applications that each team manages. And where with multi-tenancy, you strive more towards sharing this single resource, which in this case is the Kubernetes cluster, across the different teams. So that doesn't mean we only have one Kubernetes cluster within iGen. We have like 20 plus, actually. But one Kubernetes cluster serves many different teams without them being able to sort of screw up the other person's work or the other team's work. All right, so how do we set these boundaries for the developer? Well, first of all, let's recap this infrastructure and developer split off. So on the infrastructure, they provide the Kubernetes cluster, and they maintain the storage layer. So they maintain HDFS for us. And they manage and enable the tenants, meaning when a new team comes along and they want a new namespace, they create that namespace for them. Furthermore, the developers, they just want to deploy their applications and their tools, and they can do whatever they want as long as they stay within the boundaries set by infrastructure. So what does this look like in practice? We have two separate repositories. We have the infrastructure repository and the developer repository, where on the infrastructure repository, we specify all the security-sensitive items. So these are things like firewalls, which are called network policies in Kubernetes, also the required security settings for containers, so that the containers don't run with root, access control, resource limits, you name it. Anything security-sensitive is in that repository. Furthermore, we also have all these Argo CD applications. So these are the things where you define in Argo CD what you want to be deployed in each namespace. So it sort of points to a Git branch, and then it will resolve that Git branch to that namespace. So these are all defined inside the infrastructure repository, and also the boundaries of that Argo CD application. So in there, we specify what can be deployed by that Argo CD application. So all these security-sensitive items you see at the top, these cannot be deployed by the Argo CD application that's sort of pointing to the developer repo. Furthermore, any change we make here has to be reviewed by the infrastructure team. On the other side, on the developer side, we can deploy, or we have the application manifest, and we can deploy whatever. Right? So we deploy Spark, or we have the manifest there for the Spark jobs, we have the manifest for hosting MLflow, we have the manifest for Airflow, and then these are automatically deployed by the Argo CD application. And the reviews are done by the team itself. So now anytime I want to make a configuration change to Airflow, I can just go ahead, make the change, and somebody from my team can approve it, and then boom, it's automatically deployed. So what does this look like in practice? Here we have the infrastructure Argo CD application. At the top, we have some storage limits saying that you can't use more than 2 terabytes for this namespace. We define a namespace. We have the quota, meaning not more than this CPU, not more than this memory. And at the bottom, we have the firewalls. And in the middle, you'll see you have this tenant Argo CD application. And when we click on it, you see that we get back to the project that I deployed earlier, right? And now you may wonder, what happens when one of our employees turns evil? Well, okay, maybe not that evil. Yeah, what happens when a dev tries to make himself an admin? So I tried this, and I tried to deploy a cluster role binding, which would give myself admin privileges to the entire cluster, which would mean I would be able to delete and deploy whatever I want. And as you can see, Argo CD has this yellow ghost object here that it's trying to deploy this resource, but it can't because it's not allowed. And if you look further and you click some buttons, you see that the sync has failed for this specific resource because this cluster role binding object is not permitted in this Argo CD project. So thereby, we're really limiting off what the developer can deploy. OK, now we have the applications. The developer can deploy whatever. But now, if we want to connect applications together and we want to use some secrets, that's where secret management comes in. And what is that like? So again, we are open source, we're on-premise, so that considerably limits our options because every cloud has their own secret manager. we had some requirements that secrets should be accessible from multiple places without copy-pasting them around. And we didn't want developers to be bothered with encrypting secrets in the repository, because that also does really feel like a nice experience. So what we came up with was using HashiCorp Vault with the external secrets operator on Kubernetes. And the flow looks as follows. We have a team that creates an MR on GitLab to request some secrets inside our namespace. And then we have this tool called Atlantis that constantly watches this repository. And as soon as this MR is approved and the original author says apply, Atlantis will take the MR, it will apply it to the vault and merge it. And then from that moment on, that namespace has access to all the secrets. And now what we need to do is actually get the secret in there. So the team, they create a resource inside Kubernetes, which is an external secrets resource. And there it simply asks for the secret from Vault. And then the external secrets operator will fetch it from the Vault and create the secret for you. And this is very nice because in this fashion, we still kind of have infrastructure reviewing which namespaces get access to which secrets. So that's still a security layer there. And it makes it very easy for us to share the same secret between namespaces whenever that's needed. OK, then on to the final part. So what were our migration efforts like? So I think a very good idea for us was to start with applications that were widely used but not critical, because you don't want to use an application that is not that much used, that you only notice 5 weeks later that's been broken for the past 5 weeks. You will really want something that problems are noticed immediately, but it's not critical. So if it goes down for 2 hours, that should be OK. And that's why we chose to go with Trino and Spark History Server, where Trino serves all of our analytical queries, and Spark History Server contains the history of our Spark jobs, right? But we also had some new POCs, which were Cassandra and Data Hub. And this really allowed us to see how the Kubernetes cluster was functioning, and it immediately gave us some insights, mostly insights in things that we were missing, because we were definitely missing some monitoring, we were missing some logging. Monitoring, I'm just talking about metrics. With logging, I'm talking about the moment you create a deployment and you delete it and create a new deployment, you lost all the logs from your historical deployment. So that's why we needed to also step our game there. And mostly connectivity, because connectivity between pods or between nodes isn't that obvious, because that's where it didn't really go so well. We had a small dumpster fire there. Because Adyen is quite big, and we deploy our firewalls in a centralized way. And that also meant that the firewalls were being deployed to the Kubernetes nodes. But what that means is that the moment you spin up a pod and you override those firewalls, it also overrides the network policies that are just applied on the Kubernetes cluster, meaning you will lose all connectivity from those pods. So yeah, Trino and Spark History Server went down a couple times. But luckily, it was only these applications. So otherwise, we would have had a real major fire if we already migrated everything and only then we discovered it. Yeah, so the wins. We really improved in time to market. We are able to deploy new applications in a matter of hours instead of days or even weeks. Also, when people want to experiment, they want to try something new, they can just create an MR, deploy it within the same team, and it's much faster. Also, developer autonomy. Now, when I want to change the configuration, I really can do it myself instead of constantly knocking on someone else's door to make the configuration change for me. And finally, security, which is definitely very important for us. It also improved a lot because the firewalls got even stricter. It used to be that we deployed firewalls on a server-by-server basis, but now we can really limit those network policies or firewalls per application, because multiple applications might be running on the same server, right? So that's why that's important for us. And also secret management improved a lot, because when multiple applications are running on the same server, these applications can access each other's secret if they go rogue. And now the secrets are really contained within the namespace. So you can only access, the application can only access its own secrets. All right, then short summary. yeah, I showed you how we moved to containers using Kubernetes, how we wanted to go for automatic deployments over YAMLs, how we manage our secrets, and how this allowed us to achieve developer autonomy, and yeah, some tips for migration. If you want to connect, here are my socials. And well, before I end, thanks to all my colleagues. I didn't, like this slide was already very big. I didn't list everyone, but these are definitely some of the people that helped out during this effort. So thanks to all of my colleagues and the entire team. Yeah, cheers.